Welcome to Euron guys and welcome to a lecture of RAG. So in this lecture guys, I'm going to show you that how you will be able to build your own RAG pipeline. How you will be able to take any kind of a data means any private data about which LLMs are not aware about, by the way, and how you can convert those data into a small chunks, and eventually how you can convert your data into an embeddings, and then you can query it with respect to any kind of a LLMs. Now, in this entire process, you need two things at least. One is a embedding. So unless and until you don't have an embedding model, you will not be able to convert your data into its equivalent embeddings, and then you need an access of LLMs. So again, if you don't have an access of LLMs, you will not be able to query your RAG. So whatever like private data which you have converted into an embeddings. So each and everything I'm going to cover in a step-by-step manner so that you all will be able to understand things in a best possible way. And I'll be talking about obviously chuckings. I'll be talking about obviously a use of LLMs. I'll be talking about a use of embeddings in a step-by-step manner, which is a building block for any kind of a RAG application that you are going to build. And this entire simple demo has been designed in such a way that it will give you a complete understanding, a complete idea about embeddings and chuckings and LLM operation, and finally RAG operation. So let's move ahead and let's try to understand RAG. So first of all, let me draw a pipeline. So as we all know, guys, that RAG is all about querying a private data, a data about which my LLMs are not aware about, right? So this is the whole idea. So here, RAG pipeline. So RAG pipeline. Now for any kind of a RAG pipeline, any means literally any kind of a RAG pipeline. So you need a data. So unless and until you don't have a data, you will not be able to perform RAG operation. So obviously these data set must be a private one. Your LLMs are not supposed to be aware about it, right? For example, if I'm talking about maybe a Euron data, if I'm talking about some data which is like very much personal to me, so that kind of a data I'm going to consider over here. And then this particular data, right? This particular data. So what I will do is I'll try to convert this data into a chunk. So convert this data into a chunk means into a small pieces I'm going to convert this data into. Now, once I will be able to convert this data into a chunks, then I will try to do what? So I will try to basically convert this entire chunks into a embeddings basically. So embeddings is nothing but a vector representation of any kind of a textual information or any kind of a data that you are going to consider. So I'm going to convert everything into an embeddings. Now, once I will be able to convert everything into an embeddings, then I will try to prepare my query. Yeah, then I will try to prepare my query. So here I'm going to basically write a query, and this query, right? So this entire query will go to LLMs. This entire query will go to an LLMs. But before this query will go to an LLMs to like ask or for execution. So what it will do is, so it will try to, right? It will try to check even my embeddings that I have created. So it will try to check my embeddings that I have created, that whether we have some sort of information with respect to this particular query inside this embeddings that we have already created from my private data. And then it is going to combine a query. So combine a query plus embeddings, and this will go into a LLMs to get an answer. And this LLM is going to give me an answer in a complete formatted manner. So here I will be able to get my answer. So this is the complete flow, guys, that we are going to create one by one. Now, the major part over here is that access of embedding models. Unless and until you don't have access of embedding models, models which will be able to convert your entire data, your entire information into a vector space for a respective dimension. So you will not be able to perform this RAG operation. The second part is you need an access of LLMs. So unless and until you don't have access of LLMs, again, you will not be able to perform this kind of a operation. Now, the good part is that you don't have to go anywhere to access LLMs, or you don't have to go anywhere to access embedding models. You have each and everything inside a Eury system, which is a part of Euron itself. So let me show you that first of all, that how embedding happens and what will be the result that you are going to receive eventually. And then I'm going to show you even LLMs. And then I will start building this entire flow, the entire flow that you are able to see over here. So I'll start building this entire flow one by one, one by one, one by one. And then even I'm going to show you that how you will be able to productionize this one, how you will be able to deploy this one on a variety of a platform. Okay. So first of all, guys, what you have to do is you have to open up a VS Code so that we can start building things. Yeah. So here I'm going to open up a VS Code and I'm going to create a folder somewhere. So here I'm going to create a folder RAG pipeline demo, right? Pipeline demo I'm going to create. Now inside this folder, I'll be doing each and everything which is required. So here I'm going to create a file called as RAG pipe underscore demo.ipynb. You can try to execute this entire things even on a Google Colab or even on any kind of a Jupyter notebook. That's completely fine. And at the end of the day, I will be converting a same code into a modular fashion. And eventually I'll try to convert this entire things into an app. But first of all, I'll try to show you in a step-by-step manner. Now, as per this diagram, right, as per this diagram which I have shown you, you need a embedding models so that you will be able to convert any kind of a data. So whatever data that you have in your hand, so any kind of a data into its respective embeddings. Now, many of you must be confused about the embeddings still, right? That how embedding looks like and what is going to be the embeddings, and many more questions you must be having. Now, so to answer to those questions, so let's do one thing. Let's go to Euron platform, and inside that, let's go to Eury platform. Inside that, let's go to API platform. And here, so you will be able to get an access of lot of models, right? Lot of models. So lot of LLM models, you will be able to get an access, including a GPT or Gemini or Llama or maybe a Mistral or Quinn or DeepSeek. Apart from that, so we are giving you even an access of this text embedding model from a OpenAI. Now, what it does, so as you will be able to see that it converts all the data, whatever data that you are going to pass into a 1536 dimension vector. Means, let's suppose if I'm going to pass any kind of a sentence, it will try to create a vector, right? It will try to create a vector and it will try to represent those textual information or any data that we are going to pass. So it will try to represent those information into 1536 dimension vector, a numerical space it is going to convert. And that is something which is required. Now, for this, we have even given you a code example, a Python based code example. So if you will come over here, so here embedding generation, and for embedding generation, we have already given you a code in this particular place. So just copy this place, copy this code so that I will be able to show you a demo, by the way. So here, I'll try to copy this code and let me select my kernel. So any kernel which is available to me. And here, so this is a code which we have given to you, a pre-built code which is available to all of us. Now, I think I have copied this code multiple times. I don't know, but yeah. Let me remove one. Okay. Now here, so you will be able to find out a function called as generate embeddings, and which is calling my Eury endpoint for our embeddings, as you can see, right? Now, this is a payload. Payload means this is a data. So whatever data we are going to pass over here, it will try to take a help of this model, text embedding 3 small, which is a OpenAI, one of the powerful model for embeddings, and it is going to convert your data into a 1536 vector dimension. Okay, so let's try to do it, and let's try to convert it. So if I'm going to execute this particular part, but before execution, so you need a key. Unless and until you don't have a key, you will not be able to perform this operation. Now to get a key, you can click on this authentication tab, right? Authentication tab, and here is your API token. Yeah, here is your API token. So I'll just try to copy this API token, and instead of this static, so I'll try to place this copy API token over here. Okay. so that this entire thing is going to work. Unless and until you are not providing an API token, it is not going to work. Now this is a data, guys. This is one single line, and eventually I'll try to use it for converting a multiple lines as well. But here, so I'm just trying to use this particular line, a single line, and I'll try to like call this function so that I will be able to convert this particular line, which is a default line given inside a URI platform for our embeddings, into a vector space. So execute, and bearer token unlimited string literal detected line number 9. So let me check what is a issue. So I believe I have missed this one. I have to close this one. Okay, execute once again. And now if I'm going to call my generate embeddings, so this model is going to work for me, and this model is going to generate embeddings, and this is the embeddings that we are able to receive, guys. Yeah, this is the embedding that we are able to receive. Now this embedding, right, this embedding that we are receiving, so this embedding is required for any kind of a RAG application, because whenever I'm going to fire a query, so it is going to take a query, it will try to extract a respective embeddings, and then query plus embedding will go inside my LLMs, and then LLMs is going to give me an answer, right? Then LLMs is going to give me an answer. So here we are able to convert our data into an embeddings, and if I'm going to check, let's suppose if I'm going to hold it in some variable, so embed embed variable, and I'm going to like call this generate embeddings, right? Generate embeddings. So this is returning me embeddings in between. So we are trying to print something which is not required. That's completely fine, just for the showcasing purposes, right? So give me like a top 5 value of the embeddings. But yeah, so if I'm going to like do this, so here I'm going to call embed, and if I would like to check what is the size, what is the total length of this entire embedding, so it's a 1536. Means we have passed this particular line, just this line, right? Just this line, and it is converting my entire data into a vector space of a size what? So vector space of a size 1536. So embedding model is very much required. Now this embedding, what we do is, so we try to save it or we try to store it into any of the vector database. So here I will be using, in this particular example, I will be using a Facebook AI similarity search, FASI, basically over here as a vector DB. Going forward, so we have a huge chapter about other vector database. If you will check your syllabus, so we are going to talk about that as well. But here, so I will be using a Facebook AI similarity search. Now here, successfully I'm able to convert my data into a embeddings, and there is no question about it, right? There is no question about it. Now I can try to use this embedding, the embedding that I have generated, so while doing a query for a LLMs. Now, how I will be able to access LLMs? So separately, I'm able to access embeddings. So that's completely fine. So we have tested it. Now, let's go ahead and try to basically test, right? Let's go ahead and try to basically test a LLM model as well separately, right? Separately, so that I will be able to query and I will be able to generate some sort of a response. So for that, you can come to a code example, and here, so you will be able to find out that as well. So here we can try to execute this particular piece of a code. Now this code is trying to do what? So this code is going to hit my LLM. So here I'm going to use a GPT 4.1 Nano. Let's suppose if I'm not looking for a 4.1 Nano, so in that case, maybe I can try to go ahead with a GPT 4.1 Mini, Gemini Flash, or maybe a Gemini Pro Preview, or maybe a Gemini 2.5 Flash Preview, Llama Scout, or maybe a Maverick, maybe a Llama 370 billion parameter model, or maybe a DeepSeek, whatever I want. Now, the only thing that you have to do is that replace your model ID. So everywhere we have given you a model ID, right? Everywhere you will be able to find out a model ID. So you have to just replace your model ID, and then it is going to hit that respective LLMs, right? That respective LLMs it is going to hit. How? I'll try to show you. So here you can try to even set what is the number of a token that it should generate. You can even try to set a temperature over here. So if temperature is going to be close to 1, it simply means that your output will be more random. It will hallucinate more and more. If temperature will be less, let's suppose a 0.1, because it will be in between a range of 0 to 1. So if it will be close to 0, it simply means that it will try to give you more accurate result. Now here, to execute this one and to get any kind of an answer out of this, so you need again an API key. So you can try to come over here and same API key you can try to copy. So there is no different API key, same API key, and then instead of a static, right? Instead of a static, so you can try to place your API key over here. So this API key over here, and then you can try to execute. Now after execution, so what is the response that you are expecting? So this is the content that you are going to pass. Write a poem about artificial intelligence, right? So write a poem about artificial intelligence. And once I'm going to execute it, right? Once I'm going to execute it, so it is going to give me some sort of a response. And as you can see, it has given me a content in a circuits woven, silent through a take flights, mind of the code, and then this is the entire poem which I am able to receive over here, right? This is the poem which I am able to receive over here. Now successfully, right? Successfully now I'm able to test my embedding models, as well as I'm able to test my chat completion model, means LLM models. And here, like I said, so you can try to pass any model ID. For example, so let's suppose if I don't want to use this particular model, so maybe I can try to use maybe a DeepSeek model, right? So I can try to copy a DeepSeek model ID over here, and then I can try to hit, I can change this model ID. So GPT 4.1 Nano instead of that, so I can try to use a DeepSeek R1 Distill Llama model and execute it. And now this time it is going to hit a DeepSeek model, and from a DeepSeek model, I will be getting a response. I will be getting a poem, right? A poem about artificial intelligence. This is the command that we have given. Now, this is going to give me a poem. See, this is again giving me a poem, a beautiful poem, not in a formatted way. So obviously when I will try to show you the final response, so it will be in a formatted way. But here, so yes, it is able to give me a poem. So in this lecture, we are able to achieve two things. One thing is, we are successfully able to test our embedding models, which is already available. So you don't have to do anything, and it's pretty much required for our RAG application. I'm going to use it in the next lecture. Plus, I'm able to test my LLM models, which is again very much important to build any kind of a RAG application. Yeah, it's important, right? It's very much important. So with that, thank you so much, guys, and see you again in the next lecture.